Hello and welcome to the Imaging Wire Show. My name is Brian Casey. I'm managing editor of the Imaging Wire. Got a great episode for you today. Our topic is spatial computing in radiology, and our guest is Cameron Andrews. He is founder and CEO of Sirona Medical. Cameron, thanks for being with us again today. Can you tell us a little bit about yourself and a little bit about Sirona Medical?
Thanks for having us again, Brian. I am the founder and CEO of Sirona. Sirona was founded a little over a half a decade ago with the ambition of really re-architecting radiology IT. That means PACS and reporting, viewing, work list, etc., from the ground up as one unified but crucially cloud-native platform to really allow radiology practices not just to operate more efficiently and effectively, but to be future-proof against what the future of radiology holds. And part of that is what we're going to talk about with spatial computing today.
All right, very good. So let's just dive right into it. So spatial computing is a concept that seems to have kind of risen to the fore since Apple launched its Apple Vision Pro headset earlier this year, and these things are starting to get out into the wild, and you may see them around. Why should radiologists care about this?
Radiologists shouldn't. What they should care about is eye tracking. They should care about ambient voice, and they should care about their ancient infrastructure that powers radiology IT today. So when the iPhone first came out, people thought in part that the touchscreen was the coolest feature, and oh my God, look at this. And in part, like with Apple Vision Pro, people are experiencing virtual and augmented reality. It's reaching an audience that it hadn't touched before. But really, at the end of the day, what made the iPhone so powerful in terms of the way that it's transformed the entire economy, broadly speaking, had nothing to do with the touchscreen and had a lot more to do with the sensors that were included in that package and in your pocket. So it had a lot more to do with the camera. It had a lot more to do with the fact that you could combine a camera with the internet and allow things like QR codes and stuff like this to change the way that information is consumed. It had a lot more to do with GPS, which allowed ideas that had failed in the dot-com era to create billion-dollar companies. Like the idea of grocery delivery failed with a company called Webvans, famously in the late 90s, early 2000s, and then succeeded with the DoorDash and others just because a phone with GPS in it allowed for a different operating model to exist, which became the gig economy. The thing people should care about with spatial computing generally has nothing to do with the headset or like the fact that you can, watch videos in a, augmented reality or a virtual reality environment, but has a lot more to do with the sensors, which attached to a Vision Pro or attached to your computer or attached to whatever are going to have a really profound impact on radiology and make some ideas that didn't make sense and didn't work like 5 years ago, all of a sudden extremely valuable. So let's start with eye tracking. What radiologists would say the last 5 years has been is a pretty good live action demonstration of how valuable AI cannot be, given the underlying IT stack as it exists today. And if you go to what the most value that's been created with AI today, the overwhelming majority of the applications that have done well to create value for radiologists either avoid integration into the workflow altogether or had to create their own workflow in order to be able to deliver that value. And so there are things like, as an example, AI-powered segmentation of anatomy, of pathology, of what have you, which are like cool tools, but the killer app, it failed. You couldn't find a killer app for AI-powered computer vision-based segmentation up until this point. But what happens when eye tracking allows for you to look at a piece of anatomy and then have the information and lab values and other pieces of information automatically presented to you? You can look at a liver, the system knows you're looking at a liver, and therefore the liver lab values can automatically present themselves to you. That all of a sudden takes an idea that was valueless for the last 5 to 10 years and makes it something extraordinarily powerful around which you could reimagine the way that radiologists interpret exams, or at least how information is presented to radiologists. And so another example there is it's one thing for you to be able to speak words into a clinical record. Radiologists have been using transcription software for the last 15, 20 years. Like it's something that's ubiquitous at this point. And people know that speech to text is something that, has allowed radiology to, radiology is one of the first specialties to really adopt speech to text in the way in which it has. But what happens when speech is no longer about just putting the words in the record plainly, but now the actual engine of understanding, whether it's large language models or whatever the hell you want to call it, allows for you to speak like a human and for the software to do things for you, not just speech to text, but speech to action. The ability to say, something you want in the actual report, and then to say, if the patient had lung nodules in a prior chest CT, can you hang that for him? And then have that information hung. So it's not just about eye tracking, it's about the ambient voice technology that is happening concomitant to it, the two most powerful sensors that exist in that Apple Vision Pro package that are now being exposed to people.
Let's talk a little bit more about the eye tracking, because I was actually able to use one of these Apple Vision Pro headsets for the first time at HIMSS recently, and I didn't realize that it does have the eye tracking. I mean, it's looking at it's looking at what your eye is looking at. And so when you put the thing on, you go through like a little calibration test to see, where your eyes are looking at. And then from then on, as long as you've got the headset on, it knows what you're looking at. And that really, it kind of puts it at a different level than just, like you mentioned earlier, just looking at virtual reality in a headset.
That's it. And so, I mean, at the end of the day, what the Apple Vision Pro is, as a package, is something radiologists shouldn't care about. As a demonstration of what is to come, it is something radiologists need to care about. And here's why. As you were saying, like, the eye tracking is so precise that it knows exactly where you're looking. If you ask a radiologist how much time, as an example, it takes for them to measure a lung nodule, and we have a class 2 medical device product called Sirona Measure that we embed into our platform that automatically measures lung nodules. This is a test case for us in part. If you ask them how long it takes to measure a lung nodule, it's like seconds. It takes them some number of seconds. But if you ask how long it takes to be able to navigate to the appropriate set of tools, to then put those words into the report, and then to take the obvious action that would come as a result of whatever that measurement yields. The result of that can be many seconds, but it can also be minutes. The ability to look at a nodule and say, measure that, and if the dimensions of it are greater than blank, put this in the report and do this for me, make a phone call to the referring physician. It is the combination of the contextual awareness provided by computer vision, knowing what you're looking at, and eye tracking, knowing where you're looking, combined with ambient voice, combined then with what at the end of the day is just a screen. Like, you can achieve that same outcome, whether it's with a headset on your face, which is a little heavy and kind of clunky and it's a V1 thing, or whether it's hardware that you put onto your computer, onto your monitors at home. Every other part of the Apple Vision Pro is just a headset. But the sensors that are now becoming so dramatically precise because of the massive billions of dollars of investment that are going into augmented and virtual reality leave us with three things that are true. Eye tracking is going to get precise enough that it will make things valuable that weren't for radiologists before. Speech to text now can be speech to action, with large language models being where they are, which allow for new workflows to exist that could ever have existed before. And lastly, but most importantly for radiology practices today, you don't get the first two unless you modernize your IT stack. And that, I think, is the biggest issue that we as a business were founded in the principle of. How can you say, hang something and do some stuff if the speech engine is separate from the viewer? How can you look at images and have things happen in a reporting context in a deeply embedded way, unless those systems are unified? And so it's not just about the unification of these systems, which is our thesis as a business, and it's why we've been building what we've been building for the last 5 years. But it's the modern IT stack that allows for that future paradigm to exist on any compute platform. Sirona works on your Apple Vision Pro. It works on your MacBook Pro at home. It works on your PC in the hospital. It runs through the browser, so it's agnostic. And so the point there being, whatever that future compute paradigm looks like, radiology practices need, in our estimation, to focus on how they're going to modernize their tech stack to allow these two new powerful sensors with eye tracking and large language models to really reinvent the radiology workflow, which is what we believe is going to happen over the next 3 years.
Interesting. So you mentioned one potential use case in terms of measuring items on an image. What are some other possible clinical use cases that you can see for the Apple Vision Pro?
Well, I think anytime that there's a new compute paradigm, especially a consumer compute paradigm, you end up with this. What the venture firm I used to work for would call the half-life of technology intimacy. Every 5 to 10 years, the proximity of technology to our human person gets cut in half. And so you go from a mainframe to a computer on your desktop, at your desk, to a computer on your lap, to a computer in your pocket, on your wrist, and now on your face. And the point there being, the closer that technology gets to you, the easier it is to present certain kinds of information in context. And so the point there being, the whole reason people should care about Apple Vision Pro and the idea of spatial computing generally is because in a consumer context, you can present information with contextual awareness. You can look at something, the system will know what you're looking at, and it'll give you the information you need. And so you can imagine that in a lot of different contexts. You can imagine there being the ability to educate patients more effectively on what their condition, as they've been diagnosed broadly, what it means, and help to create a better consumer experience there. And I expect that'll be one of the first use cases because it's unregulated. You can imagine the ability for radiologists to tag information in the images that then is viewed in context by the surgeon in surgery. You could imagine then radiologists playing more of an active role, not just in interpreting those images, but in guiding the surgeon through what they should be doing to help care for that patient ultimately. There are many different examples of this that you can point to that say, if now the computing paradigm is spatial, it's three-dimensional, what kind of data can radiologists create and pass back to referring physicians that makes the radiology product more valuable? And so my point there being, there are many use cases that one could imagine here that, because radiology is by definition a spatial profession, it is data that is broadly three-dimensional or at least 2.5-dimensional, those use cases abound. And so I think most profound impact on radiology will be on the enterprise side. It'll be the radiology workflow in one way or another. But there will certainly be many others that help bring radiology closer to the operating room, help bring radiology closer to other parts of the care process.
What about interventional radiology? Because right now, some of the folks that are using, virtual reality, extended reality the most prior to the launch of the Apple headset were interventional radiologists, with headsets that would overlay images on top of real patients. Do you see the Apple headset moving that forward dramatically, or is it just sort of an incremental development?
Incremental. And the reason there being, ultimately, when you look at from an algorithmic perspective, the ability to create the level of precision that would improve an interventional radiologist's ability to do their job is a level of precision that cannot be accomplished with just a headset alone. And so 2-3 generations from now, maybe I'll eat those words, but in that respect, incremental, but it's so cool. I mean, it's so cool that you understand why people want to try it, because you can see where that future is going to be. But the extent to which there is something that can help interventional radiologists versus improve their ability to do their job, I think the gap between those two is a decade.
Yeah. Now, do you ever see a situation or a circumstance in the future where radiologists would actually be interpreting images with these headsets on, or do you think the technology? I mean, you mentioned earlier that the technology could be embedded in maybe some sort of camera on top of a traditional monitor. I mean, would that maybe be a way to implement eye tracking that's maybe not quite as onerous as having to walk around with one of these headsets on your head?
I think it's going to be a preference, but I think people will use the headsets. I think people will use their own computers. And that's where I think the conversation about spatial computing becomes muddled. Will people read in these? Sure. I mean, I watch movies in it now. I got a TV. I put it on and I watch movies and it's awesome. And so the point there, but just because it looks and feels like a theater, that's a personal preference. But my mom or my grandmother, no way in hell would they ever decide that that's how they want to spend their time with the headset on watching movies. And so it's a personal preference. However, the paradigm that we're describing is independent of just where those sensors are embedded. But over time, it's obvious that this technology will continue to improve so that you could imagine a world in which radiologists are wanting to spend all day, every day in these headsets. That is not this generation. I imagine just geometrically, it won't be the iPhone 2, but the iPhone 3 that people say this is a toolkit now that I need. So I believe it'll be the third generation of the technology that tends to be geometrically how these big tech businesses design and then roll out the tech. V1 is like for the earliest adopters, V2 is for 10% of the market, and then V3 is for everybody. And so I think we're within, 3 to 5 years of that moment. Right.
Now, a couple of vendors have already launched radiology applications specifically for spatial computing, and they showed some of at the HIMSS show recently. You mentioned Sirona and how your tech stack is more amenable to spatial computing. Do you see the need to develop specific apps for it, or do you feel like what you've got in hand is already suitable?
I think there are two parts to this that get really nerdy, but radiologists should care about this. And I'm going to start with an anecdote that I think is important. In the last 6 months, the world's compute power, the online compute power of planet Earth, has gone up by 50%. We are at a moment in time where I've seen the first meaningful demonstrations of what I think now is fairly well understood. The gap between us and AI being 10 times, 100 times more powerful than it is now might just be a function of compute power. And so the point there being, if you thought you could put servers in the basement and get the best AI yesterday, there's absolutely no way that any hospital or health system of any scale could justify the infrastructure investment on their end alone to put the amount of horsepower in a basement necessary to get cutting edge AI in that basement. That is something that is not my opinion. It's a fact because in the last 6 months, the amount of compute you need went up by 2. What are you going to do? Buy it now and then realize in 6 months you need twice as much compute power? Businesses can't operate that way. You have to have the compute cost of AI be variabilized, which means you need a cloud native architecture. And so the point of like cloud, native apps to one ecosystem or another, that's what doctors shouldn't care about. They shouldn't care about an iPhone app versus an Android app versus a whatever. It's incumbent on the developers to create the end experience for the radiologist that is best in that environment. However, the biggest lift and shift for radiology isn't the front end application. It's the entire infrastructure behind it. And so my point here, and this is to answer your question, the fact that today's IT vendors have to rebuild everything for this new paradigm is precisely the problem. Sirona today, you can log on in your Apple Vision Pro at app.sironamedical.com and you can use the entire application there. You can use it on your iPad, on your iPhone. You shouldn't, because diagnostically you should be doing it on your computer. So don't do that. But it works, and all of it works, and all of it works just as well as it would on your computer. But that's because we built the system not for one ecosystem or another, but for the web. And the one thing we can be certain of is whatever the future compute paradigms are going to be, they are going to be internet enabled because our entire society is internet powered at this point. And so the point there being, we have created an infrastructure. And again, we are biased in this respect because this is why we've spent the last 5 years building what we have with our partners and brought to market in November, is that infrastructure challenge, putting all the data radiologists need next to and in a cloud native infrastructure that has all the compute power you could ever want in a variable cost model. That requires cloud native re-architecture. That requires a ground up rebuild, not the development of an iPhone app or an Android app or an Apple Vision Pro app to accomplish that. So whatever the end consumer experience is, nobody's going to care. What people are going to care about is whether or not they're able to get all of these powerful sensors at their disposal, which they can't, unless the entire heart of what these legacy IT solutions are today is entirely rebuilt.
Yeah, wow. Some great thoughts. You mentioned the launch that happened in November. How is that going?
It's been great. I mean, we were very fortunate in so much as we were lucky that, or I should say strategic, in so much as we were already partnered with, some percentage points of the market. I think maybe 3% or 4% of the US radiology market we were partnered with beforehand by number of physicians. Today we have something like 5% of all US radiologists represented between the practices with whom we're currently contracted. And we have the 15 groups that we referenced in our launch video that we've been working with, but that should double within the course of the next 3 months here. And we're fortunate that, we're able to help care for and provide value to businesses of all scales now. So our core platform is the best product in the world for somebody somewhere. And that somebody is small, independent, private practice groups with a fragmentation problem today. We're about 18 months, maybe 24 months away from being the best for everybody everywhere. But in the interim, we can create material value for practices of any scale because we've built everything. We can provide parts of it to anybody in ways that create value. So we can replace your existing reporting solution. And we can do that for relatively pennies. We have a business continuity platform, which means you can use all of Sirona in order to read as many cases, or probably to read cases when your existing infrastructure is in a downtime. You can use our platform as an AI innovation platform to access the small handful of partners we currently have. And we are able to offer that to our customers at about an order of magnitude less than what it costs customers to use Sirona as their full primary workflow. So we have 2 offerings that we have in the market today, our core flagship product, which we call Unify, and then a way to access Sirona, which really amounts to being able for these large hospitals and health systems who want to be future-proof, they want to modernize, but they don't know how to start, to have more of an incremental step-by-step approach to modernizing their IT stack in the way that they know is necessary. So I think the fact that the launch went as well as it did, we had over 20,000 people watch the launch video, and we're very fortunate to have had the response that we did. And our job is to make sure that we do not sign up so many customers that we cannot deliver to them appropriately. So that's our commitment to our market at this point, is we will not sell software to people we can't be the best solution in the world to, and we will not put ourselves as a business, as so many other vendors have, where they are not in a position to be able to deliver those solutions and deliver on their commitments. We would rather have half the revenue and not one unhappy customer than the other way around. And I think that's a big difference between the way our company is structured and the way that a lot of the legacy vendors have to operate because they're publicly traded.
Yeah. All right. Very good. Well, some great discussion today. Cameron Andrews of Sirona Medical, thanks so much for being with us.
Thanks for having me, and everyone should go buy an Apple Vision Pro. They're way too much fun, and it is a tremendous way to waste an afternoon or to waste a weekend, and a very expensive one at that. So there's my plug. For the Apple.
I'm going to go out and get one too.
All
right. Signing up for the Imaging Wire, my name is Brian Casey.